Next, I'd like to introduce Arin Sime. He's owner and founded a development shop they called Agility Feet, initially focusing on agile development. They got it into webrtc recently. I guess you have another brand, webrtc.ventures. I'll let you explain a little bit more. Arin's he's a great expert in this. Covers a lot of different aspects. Really likes to play around and explore what you can do with webrtc. And I'm really excited to hear what he's going to talk about with putting webrtc into things. So with that, I'll let you take it away, Arin.
Thanks, Chad. Appreciate it. So as Chad said, my name's Arin Sime. I'm CEO and founder of webrtc Ventures, also sometimes known as Agility Feet. We've been designing and building custom webrtc-based applications for a couple of years now, and really interested in it. But webrtc can be about so much more than video chat, and many of you here are involved in this enough to know that already. But we're just really starting to see the potential of webrtc and the Internet of Things coming together. So that's what I want to talk about today, and just throw out some ideas of a couple of things that we've done, but also probably more of the examples I'm showing are from what other people have done, to hopefully just kind of stir up the creative juices a little bit for how we can go beyond video chat with webrtc. So I don't know how many of you maybe have seen this particular stock photo before. I know I'm guilty of using video chat stock photos all the time in my presentation, so I'm going to try and make this the last one here. But even when we talk about the Internet of Things, which in many cases doesn't have anything to do with video, in our case when we're talking about how do we combine webrtc with the Internet of Things, there's still often a video component. We're not going to really get away from that, so to speak, because the combination of video with the data is part of what makes a combination of webrtc and the Internet of Things together interesting. The data channel of webrtc is certainly one of the reasons that it has appeal beyond a pure video chat application. The fact that we can make not only the video and the audio, but also data exchange, peer-to-peer and encrypted, can be appealing. And there's a number of different things that we might typically use the data channel for. The most common is text chat to go along with your video and audio chat, right? But beyond that, we can also use the data channels to control devices, to send commands down to them, to read back measurements from sensors and display that in the application, maybe send alerts, emergency alerts from a device back to users. Telehealth is definitely one area where I see IoT and webrtc on a crash collision course. Okay, we already see a plethora of personal fitness wearables out there that stream data about our activity and health for analysis for us personally, or maybe for companies gathering that data. So certainly it makes sense that in the near future we're going to see more and more cases where actual medical devices beyond personal fitness, actual medical devices are being sent home with patients as well in order to gather data and stream that back to the hospital or to doctors for improving your care. So the combination of the Internet Things and healthcare is certainly already starting. And telehealth is definitely an area of great interest in webrtc in general. Maybe I'll just ask real quick, how many of you here maybe are working on anything telehealth related? A few, yeah. It's because of the peer-to-peer and the encrypted exchange of data, it's very appealing in the healthcare sector and any sector where privacy and security are very important. So we've had a number of potential clients talk to us about combining sensor data in with or other types of data in with telehealth conversation. One quick example I want to show that this video is from is a tool we're building for a company called MedZed. And you see a standard one-on-one video chat between myself and one of our developers, Nestor. But at the top, there's also a black bar that says stethoscope. And every now and then you see a couple of green dots bouncing on it, showing that there's sound coming through from a remote digital stethoscope. In reality, he's tapping on a microphone, but we've tested it with a real stethoscope and it works. And then alternate cameras as well, so that he can show us, the injury that we're examining remotely, for example. In addition, we can imagine many other types of sensor data being combined. This little video is from an Apple Watch prototype that we made at a TAD Hack in Chicago last fall, where we're using the heart rate monitor on the watch and an algorithm that we found to try and detect if you're having a heart attack, and then to automatically notify your loved ones by SMS and a text-to-speech phone call to let them know where you are and that you're having an emergency. Now, in this particular prototype that we made, there's no WebRTC component to it, but there certainly could be, either for making a call or maybe to live stream video from where you are when you've had this heart attack, for example. I don't see anyone wearing a Google Glass today. But if you don't mind me including Google Glass in this presentation, I do think it's an important part of the Internet of Things and wearable devices like that in general. This video here is from a demo of a prototype called HC View by Paul Zotek, and showing using Google Glass for remote telementoring and surgery. And certainly we know that the first version of the glass was not a real big hit with consumers, but the word is that Google's planning on the next version to target more industrial uses, warehouses, factories, remote field support, not necessarily a consumer use, telehealth and remote surgery. So certainly the capability to live stream video from a Google Glass, perhaps using WebRTC, is something that many more of us may be working on in the future. So we've played around with that a little bit ourselves for one of our clients. This is my business partner, David Alfaro, using his Google Glass. And he's going to show us how to mix a grasshopper cocktail drink. There he is in his living room getting ready to prepare it. In working on this little prototype that we did for a client, we ran into a lot of challenges. It's hard to work with a glass. If any of you have worked with it before, you probably know that. It's bleeding edge stuff. To get good video quality in the smaller video there is the glass. The other window obviously is us on a hangout just talking to him as he uses it. Dealing with grayscale video, getting a color, the first version of the glass heats up very easily when you're doing anything CPU intensive like live streaming, and that causes the connection to drop frequently. So that was a definite challenge for us in implementing with it. I didn't let you see him finish the drink, sorry. It was actually green. If you're going to do anything like that, the architecture is going to be basically the same. The Google Glass pairs up with an Android app, and that app needs to go through the normal WebRTC signaling process. In our case, we had Socket.io on a Node.js server. The app itself, we started with a project that we found on GitHub from PChab called Android RTC, and Project RTC is an example of how to live stream from Android. And we also had to compile WebRTC from Google ourselves from the source code in order to modify some of the parameters to tweak things and get the color and the performance tuning in order to get it to work well enough on the glass. But once you, like anything else in WebRTC, once you get through that signaling process, then the app is on an RTC peer connection, a direct peer-to-peer connection with anyone browsing it. This is sort of a video chat stock photo. Sorry about that. But annotation is something interesting to consider in the Internet of Things, too. In this image, it's from a TalkBox announcement of a video annotation widget library that they've released. And this shows the most common type of use case discussed for annotation, which is having like a technician out in the field holding up their phone to the thing that they're trying to repair, an expert back at headquarters annotating on the video for them live. Cut the green wire, not the red wire, right? Very important. So having some annotation in a situation like that could be helpful. So that's a great use case for video annotation, but it's not necessarily Internet of Thingsy. But I think that we could imagine using those same libraries to perhaps overlay sensor data on top of the video and have that integrated more within the experience, or to perhaps imagine that you've got a WebRTC-based security system scanning the room, and it notices a door open that shouldn't be opened. And so in the video feed, it uses annotation perhaps to indicate that door, highlight that part of the video. So although I haven't seen use cases of this yet, I imagine that there's a lot of possibility to use annotation on top of the video from devices as well. So that brings me to WebRTC and home automation and home security. Certainly a lot of potential here. And so I'll give a first tip of the hat here to our own Chad, who won a TAD hack with his Third Eye application here, where basically he's using a sensor to detect when the fridge has been opened, and then capturing video of who keeps leaving the fridge open in his house. And he shamelessly caught his own daughter, and very incriminating evidence that she's the one who leaves the fridge open, right? But beyond keeping Chad's electric bill low and his fridge closed, there is a lot more that you could do around home security and automation with WebRTC, right? So this is a big area, in IoT in the consumer space. Home automation is obviously a very big vertical. And so one commercial example is the iCam Pro, which is using WebRTC not only for streaming the video, but they also have built into the application motion detection and having the camera track objects moving through the room, so going beyond just standard video there. And what about industrial WebRTC use cases, or WebRTC kind of on the factory floor? Frankly, I've had trouble finding public examples of that. Perhaps you know of one and can tell us about it in the Q&A or later. I don't know, is that an indication that WebRTC is just not appropriate in those use cases for some reason? Or is this an indication that it's an untapped opportunity that maybe some of us in the room here should be putting some effort into? I'm not really sure, to be honest, but the idea of combining sensor data in an industrial setting with video makes a lot of sense to me. Imagine a scenario where you have a machine on the factory floor overheating, right? You're going to have some sort of real-time sensor data coming back to a control panel somewhere. Well, if we know that the machine is overheating, why not also use that to automatically trigger a camera feed, looking at the machine to see, is it actually on fire? Is it smoking? Has something jammed into the machine? What's going on there? So taking something that, sure, you could implement that sensor data purely over, say, a WebSockets connection, but why not also combine it with video and create a richer experience there? So one area definitely that you see some fun examples of is WebRTC in drones or robotics. So the video that I'm showing right now is a robot demo that somebody made. The link is in the slides to a full tutorial on how to build this one on Instructables. And it uses an Android phone to stream video from an RC car and a Raspberry Pi to control it. And more on the commercial side, also at the Cranky Geek event that Chad mentioned a few months ago in San Francisco around WebRTC, a company called Skidans talked about also incorporating WebRTC into public safety and drone applications. They acquired EasyRTC and are using that to combine WebRTC with an IoT and robotics platform. So that's an interesting company to watch. But I think that whole vertical of WebRTC and robotics has an awful lot of potential. One interesting thing to note about the video I was just showing you on the previous slide of the RC car driving around and streaming video back from it. This image is from the Instructables tutorial of how to build that car. They call it the Creeper drone. What this shows when you take a little bit closer look at it than perhaps you can see on the slide here is that the Android phone is using WebRTC, of course, to stream back to the Command Center website. But the commands that they're sending, the Creeper commands and the status updates are all done over the WebSocket connection rather than WebRTC's data channel. And I think that's something interesting to consider because intentionally the API of the data channel is similar to a socket connection. So they look very similar, but the WebRTC data channel does have two key differences. Once you need something like WebCircuits to do the signaling to establish the RTC peer connection, right? But once you have that connection, if you're using the data channel, then all of the commands and the data that you exchange are peer-to-peer. So they're not going through a central WebSocket server. So maybe that's appealing in your use case in order to keep load off of the server or to reduce latency of the data or commands. If it's a peer-to-peer connection directly between the browser and the robot, the latency is going to be lower than if it has to go through a WebSocket server, right? So that's an advantage. And also, although you could certainly encrypt the data going over WebSockets, it's encrypted by default on the WebRTC data channel. So if the security of that data or the latency of that data is important to you, then using the data channel from WebRTC is appealing. But in this case, they just use WebSockets. Maybe it's just easier. So it's a choice for you to make when combining WebRTC with IoT. And one last just fun example I wanted to show you here. This is a little street cleaner bot, similar to the Creeper drone one, using a Raspberry Pi for control and streaming WebRTC back to a browser. This was a project by Altanay Bisht, who is author of the WebRTC Integrator's Guide, and she did this as part of a Barcamp project in Bangalore. So just another example of combining video and the remote control there. And link to a little more information on that is in the slides as well. So I hope this short little bit of time together inspired you to think a little bit beyond video chat, a lot more that you can do with there. Obviously, the Internet of Things is still very much in its infancy, but so is WebRTC, so this is a good time to join forces. And if you're working on anything cool in this space, I'd certainly love to hear about it. I don't know if I mentioned it at the beginning, I think I forgot to, but in addition to running webrtc.ventures, I'm also editor at realtimeweekly.co, which is a weekly newsletter around real-time topics, including a lot of focus on WebRTC. So if you've got some cool applications of WebRTC and the Internet of Things, please send them my way, and we'll be happy to share them with the community. Thank you.
Thanks, Arin. We have any questions for Arin? I could ask if you just come up to the microphone. We're gonna be taking a break after this anyway, so you don't have to worry about sitting back down. But maybe Chris, I know you can speak loudly. You can. So go ahead. Yeah.
Thank you. So seems the conventional thought is for critical tasks like healthy monitoring or the security monitoring, the talk to server may be more reliable than P2P. So do you think this statement is wrong, or the new generation of WebRTC can change it? Thank you.
It's a good, so if I understood the question right, repeat that back. You're suggesting that it may be more reliable to go over WebSockets than over the WebRTC's data channel. So if the data being exchanged is really critical,
Yes.
is that a better choice? It's an interesting question. You do have the unreliable versus reliable data channel setting in WebRTC. So If just getting the data there super fast, but not guaranteeing the arrival of all the data is important to you, you can choose unreliable and get it there a little faster, or the reliable setting will make it a little slower, but make it a little more guaranteed to get it there. I'm not sure, I mean, as long as you have a valid peer connection, that should be just as reliable as any sort of guaranteed delivery over WebSockets. But if you have a central messaging server that you're sending everything through, I think you could certainly make a case that that's more reliable, because at least especially if you have multiple peers who are receiving this data rather than one person. And probably that's the most common reason you might choose to send the data over WebSockets rather than the data channel in WebRTC, is if there's more than one person receiving that data, then certainly after a few users, you don't want them to all have to have those RTC peer connections with your robot.
Great, thanks.
Thank you.
Please come up. If you ask a question, you get a free T-shirt. So please grab one from Giorgio. All right. Oh, here, use mine.
Hello, testing 1, 2. There it goes. Hey, this is actually a good follow-up to his question. My company is working with a large sensor company out of Germany on a project that leverages crazy sensors in factories, kind of like what you were talking about.
Awesome.
And one of the things we are experimenting with along those lines of why you would want a WebRTC data channel is kind of the idea of like a mesh network, where you can actually use the peers to actually pass the data between. The other thing that I would make a comment about that too is that a WebRTC peer can also be a server. We have a product called Red 5 Pro where we actually become a media server via WebRTC peer. And, you know, there's Corrento too, which also does that. So always thinking of it as a client is not always the right way to think of a WebRTC peer. And yes, there are things like factory automation and other kinds of cool stuff going on with WebRTC.
Awesome. I'd love to talk with you more afterwards. Can I ask him a quick follow-up to that?
Yes.
Okay, quickly. So you want to do a mesh network with that. Is that because it makes it more reliable than having if the central server goes down? Is that the thought, or?
Yeah, also bandwidth. Sometimes you want to be able to pass between, they have like locations. I can't talk too much about it in specifics, but
Sure.
like imagine.
Not on video anyways.
Like imagine warehouses, like, and then you can pass them between.
Sure.
Things.
Awesome.
I don't know.
No, that's great.
So,
Thank you.
because we need to take a break after this, I'd say why don't we take one question here, and then I'll ask Arin just to hang out here, and you can ask him individually if you don't mind.
Yep, sounds great.
Just a quick question.
Go ahead.
What you've got on these little devices is you don't have a lot of processing power. What kind of horsepower you need to run our WebSockets or RTC on a little device like an Arduino?
I don't know exactly what the minimum bounds would be. Certainly we ran into that as a problem on the glass, and the first version of the glass couldn't handle very well live streaming for a long time. I guess the good news on other devices is that Raspberry Pi 3 just came out this week with more processing power, so you know, given a little more time, it's only going to get better. And I've certainly seen, even with relatively limited capability, size of Raspberry Pis up to this point, people doing enough stuff with it that it seems to me it's workable. Great question.
Hi, thank you for your presentation. It was quite insightful. I want to kind of talk a little bit about the healthcare part. Mm-hmm. So what kind of barriers have you had to deal with, the regulations dealing with your healthcare partner? You know, doctors doing annotations, doing the wrong thing. There's kind of a lot of issues with that. So what issues have you had with it?
It's a great question, and obviously really, really important in telehealth. And the short answer is that we, as a service provider developing it, I guess you could say we get to push some of that responsibility to our clients. But obviously, when developing our part of the software, we have to make sure that logging of any actions, you know, like text messages or changes to the system and general HIPAA compliance stuff that you have to take into mind around user authentication, security, and logging, and roles, and all of that stuff just becomes really important. So certainly, WebRTC by itself doesn't make an application HIPAA compliant by any means. And there's a lot that still has to go into it, but the peer-to-peer, the encrypted nature of it, at least makes it possible.